Hello, everybody. Thank you so much for joining us. Today is the first in a series of two webinars that is co-sponsored by RTI International and the Washington Statistical Society. The second one will be held towards the end of July, and it will cover artificial intelligence and the future of survey research. Today's expert panel discussion will be on, as Patrick said, small area estimation and the future of survey research. I am your moderator for today, Marcus Brzozowski. I'm a fellow at RTI International and a fellow of the American Statistical Association. We have an excellent panel for you today, who will introduce themselves momentarily. The way today will work is I have a series of questions that I will ask that we hope to take about half hour, give or take. And that should leave about 15 or 20 minutes for the live Q&A. We received some questions in advance from you all when you registered, as well as any questions that you enter into the Q&A, we'll try to get to them. Questions that are asked today that seem pertinent, as well as questions we can't get to, we will create a Q&A document, and it will get posted to the event page where also the recording for today will be, as well as these slides that the panelists will discuss. With that, I want to spend all our time with the panel, so we will get right to it. So my first question is for the panel to introduce themselves. And so we will start with uh, Matt Williams. Please introduce yourself.
Thanks, Marcus, and thanks so much to the organizers. It's really an honor to be here. So I'm a senior research statistician at RTI. I worked for about 10 years, a few different agencies in the federal government. Um, my key areas of interest are really using Bayesian statistics and Bayesian models to build a bridge between survey statistics and other areas of statistics. For instance, privacy protection, data combining, and small area estimation in small domains in time and space. It's really an honor. I've been involved in some pretty cool studies. The National Survey of Drug Use and Health is a huge one with SAMHSA. I've been working with privacy preserving machine learning with the Bureau of Labor Statistics, and also a synthetic public use data file with the National Science Foundation. Go ahead. So small area estimation. I'll try to fight the imposter syndrome here. There's so many excellent colleagues both on the call and on the panel. But I've had the pleasure of being involved in a few projects that are really interesting. Started in Department of Agriculture, learning about supporting county level estimates for all kinds of things, crop yield, cash run rates, things like that. Also have some experience in the public health side, again on the National Survey of Drug Use and Health, just learning so much from what was developed, 20 plus years ago and still is cutting edge. And then more recently working with National Center for Health Statistics, working on the National Health Interview Survey state level estimates. Um, but in addition to that, there's also a small area estimation for employment and for business characteristics. And so I've had the opportunity to collaborate with folks in those areas as well. So I'm excited to be here. Hopefully I can provide some insights and suggestions. I'm also interested to hear what the other panelists have to say. Thanks, Marcus.
Thank you, Matt. Thank you for being here today. And the next person will talk is Stephanie.
Hi, yes, I'm Stephanie Zimmer. I'm a senior statistician at RTI, and I think of this panel, I'm the newest in SAE, but definitely starting to learn and see what it can do for lots of projects. A lot of my research and work has been in sample design, and I really like working in sample design because you can think about how your data will be used later, but we can't do everything with sample design and thinking of all the different cuts of what we can do and so that's where small area estimation really helps out when maybe a design won't support all of the estimates directly. I'm involved in a few different uh, organizations like the ASA, the North Carolina chapter of ASA, SRMS, and Our Ladies. And in all of these, I get to learn about different statistics and help with others. Next slide. So with SAE, like I said, probably the least experienced on this panel, but learning a lot. My first experience with SAE was with the National Crime Victimization Survey, and this was developing a practical guide for SAE for the NCBS. Other researchers, namely I think Bob Fay, did a lot of work on this, and we helped to write a guide to show step by step on how the SAE was implemented on NCBS, which can really provide a foundation for other studies. I think that's a good use of this guide. And then working with Matt and others at NCHS and at RTI on SAE for the National Health Interview Survey. And it's in progress to get a paper out about this and to hopefully get the estimates out. Yeah, next.
And next, I'll let Ben May introduce herself.
Thanks, Marcus. Yeah, my name is Ben Liu. I'm a mathematical statistician at the National Cancer Institute. At NCI, I provide statistical consultation and collaboration on survey methods within our division. I mean, Division of Cancer Control and Population Sciences. I also provide consultation across NCI on survey methods. In addition, I lead and collaborate on cancer surveillance and methodological research. I also serve as a program director for NIH grants and contracts. My primary research interests include small area estimation for cancer-related measures, Bayesian spatial temporal modeling, joint point regression methods for complex survey data, multiple imputation, record linkage methods, and tool development. My PhD dissertation was on hierarchical Bayesian estimation and empirical best prediction for small area proportions, focusing on low proportions. Dr. Patalahiri was my advisor. Prior joining NCI, I worked at Wested for 7+ years. During my time at Wested, I had the great opportunity to work with Dr. Graham Cotton, Dr. John Rowe, Dr. Leela Mahasar, and others to develop small area models to produce state and county level estimates of the proportion on adults with below basic literacy skills. I wanted to highlight this because I benefited greatly from this hands-on experience, which later enabled me to lead several small area estimation projects at NCI. So at NCI, I have been leading and developing several long-term ongoing small area estimation projects utilizing large-scale national surveys, including the National Health Interview Survey, births, tobacco use supplement to the current population survey, and our NCI sponsored the Health Information National Trends Survey. Most of these projects are collaborations among multiple agencies. For time limits, I don't provide details. If you are interested, we have a website, se.cancer.gov, includes the methods and the productions from those projects. In addition to the effort applying small area estimation using survey data, I also laid a couple efforts applying small area estimation techniques, including spatial temporal modeling, to population-based cancer surveillance data. A most recent effort is disease mapping for cancer incidence. We have developed interactive time series visualization maps using a sample of like a large range of cancer sites. This is an ongoing effort. We will expand to like more cancer sites and hopefully this will be a good product to be released for users to use. We are seeing growing interest in small area estimates in the cancer surveillance field, and we expect increasing research efforts to be devoted to this area in the near future. We also have been seeing like grant applications on this topic. So looking forward to more research on this. Thanks.
Thanks, Marcus. I'm Partha Lahiri. I'm a professor in the Department of Mathematics and Joint Program in Survey Methodology at the University of Maryland, College Park. I directed the Joint Program in Survey Methodology from January 2021 to June 2025. I listed some of the selected awards. I'm a fellow of American Statistical Association, fellow of Institute of Mathematical Statistics, elected member of International Statistical Institute, and I received few awards, among them 2021 SAE Award, and I recently gave 33rd Maurice Hansen Lecture in Washington, D.C. area. Some selected professional services include, I'm right now president of International Association of Survey Statisticians. I did a lot of professional services, among that chair of U.S. Census Bureau Advisory Committee of Professional Association in 2006, an advisor consultant for about 11 organizations, including United Nations Statistics Division and the World Bank. So let me talk about some of my SAE activities. So I published papers in different research area, and small area estimation is one of them. I published more than 75 peer-reviewed articles on small area estimation in professional journals. I delivered more than 20 keynote plenary speeches on small area, and this part I like, supervise SAE dissertation research of more than 25 PhD students and postdocs. I offer a lot of short courses and workshops, like recently I did ISS ISEC hybrid workshop on practical SAE, implementing solution using multiple data sources last month. And then International Association of Official Statistics training program on small area estimation in Poland in 2022. I did one UNCAP training program on statistical analysis of disaggregated SDG indicators for inclusive development policies in Japan in 2019. I advised Chilean poverty mapping project. I served on many committees and advisory board. One of them is U.S. National Academy of Science panel on estimating children eligibility for school nutrition program using American Community Survey, and served on advisory and program committee of several SAE conferences. Next one will be in Vietnam, so I'll encourage you to attend that one in 2027 as a satellite to World Statistics Congress. Thank you.
Great, thank you guys. That's our panel today. So the way this will work, as you saw, we took the slides down. So we're going to try to keep this as informal as possible. I will ask questions that the panelists will answer, and once we exhaust those, we will open it up to the questions that you in the audience have submitted. So without further ado, I will get started. The first question, we'll start with Ben May. Do you think the current challenges facing federal surveys, for example, lower response rates, higher data collection costs, is an opportunity to incorporate small area estimation more into their designs and analytic plans?
Thanks, Marcus, for the great question. The answer is yes, I believe so. The pressures of declining response rates and the increasing data collection costs make small area estimation less of an optional post-hoc analytic tool and more of a strategic component of survey design. Integrating SAE from the outset allows agencies to plan more effectively in several areas. I believe it could include sample allocation, optimize sample sizes across domains to support the anticipated model structure, rather than focusing solely on national or like a large domain direct estimates. Data integration, establish data sharing pipelines with administrative and other auxiliary data sources before data collection begins to ensure high quality covariates for modeling. You know, as many of us know, that covariates is the key for small area estimation techniques. And the third area we could consider is a resource optimization, intentionally accept smaller sample sizes in selected domains because the design anticipates model-based estimates, allowing resources to be redirected towards reducing non-response bias or improving data quality otherwise. That said, SAE should be complement, not replace the traditional survey methodology. The quality of model-based estimates depends on the quality of the underlying survey data, the availability of reliable auxiliary information, and the validity of the statistical model. If the base survey suffers from substantial unaddressed non-response bias, SAE cannot eliminate that bias, but it may simply propagate it into the small error estimates. Ultimately, designing surveys with the SAE in mind enables agencies to make more efficient use of limited resources and provides an opportunity to modernize survey methodology in response to today's operational challenges. If I have time, I can share a recent example. We at NCI recently faced a related trade-off while planning the next wave of the tobacco use supplement to the current population survey. As you may know, a typical 2S CPS cycle consists of 3 months of nationally representative CPS data collected every 4 to 5 years. But with the most recent cycle fielded 2022-2023, when planning for the upcoming cycle, the Census Bureau's scaling constraints forced us to choose between two choices: delaying field work until 2028 to 2029 to obtain 3 months of CPS sample, or fielding sooner in 2026-27 within only 2 months of data. After considering the benefits, like the timing, strange, and restrictions, and like the sample size, we considered small estimates into the design plan. We eventually choose to field the 2026-27 despite the smaller sample size. So incorporating SAE into the analytic plan became an explicit strategy for offsetting the loss in sample size while preserving the timeline of the survey. This example illustrates how planning for SAE can support informed design decisions whenever operational constraints require trade-offs, not just when response rates or costs are the primary concern. I'll end here to provide the opportunity for others to weigh in. Thank you.
Yeah. No, thank you. That was great. Wonderful. So yeah, so let's go through everyone else quickly. We'll do it in the order of, for this one, Stephanie, Partha, and then Matt.
Yeah, I definitely want to echo, like I said, a lot of what May said. That, like I said at the beginning, I like thinking about sample design. And so when thinking about sample design, when you're working on that, to think towards SAE, and it would be the most efficient use case of SAE. Often, and it still can work to use SAE post hoc, as was pointed out, but I think to plan that and not see SAE as a if we have extra money sort of analytic task, but a task up front and included in that initial budget is important, I think, and easy, hopefully, to justify the cost up front to weave it into the entire design plan. Yeah.
Okay. Partha?
I basically agree with Ben May and Stephanie, and I believe that SAE should not be a replacement for the high quality probability survey, but it can definitely help. The problem with low response rate and skyrocketing data collection costs are massive catalyst for us to change how we design and analysis data. And when we talk a little bit about that, this is exactly where small area estimation transitions from a theoretical luxury to an operational necessity. We should not view small area estimation as a post hoc patch to fix broken data. Instead, we need to build it directly into our initial analytical plans. By intentionally planning to borrow strength from administrative data or local registry right from the start, we can deliberately design smaller, low-cost surveys without sacrificing the hyper-local granularity you need to make decisions on the ground. That much I can say. Thank you.
Thank you, Matt.
Yeah, in the interest of time, I'll just say that yeah, you don't want to do it post hoc. If there's an issue where data collection has to stop or something, that's not necessarily smaller estimation is not necessarily going to get you off the hook there. You still want that high quality data, and the more you can incorporate it into the upfront design, the better off you are.
All right. Thank you. Okay, question 2 from me. And this one will go to Partha first. To your knowledge, and then obviously to everyone on the panel's knowledge, are there areas where SAE is not currently being utilized, but you think it could be helpful?
Okay, to start this discussion, I would like to state at the outset that a lot of times when we say small area estimation, we have immediately think about geographical area, right? But the models, methodology that we have been using, and we have quite a bit of models and methodology in the literature, that can be applied to a similar problem where granularity may mean, maybe demographic domain by age, race, sex, ethnicity, for example. It could mean in time domain, I will give a quick example. For example, we may have a survey that we do every quarter, right? And then we may need similar information monthly. How do you do that? It doesn't seem to be a small area problem at the beginning, but we can borrow knowledge from small area literature to see how we can use the ongoing survey data along with administrative data and census data to improve on it, right? Now, sometimes conducting a large-scale survey is not feasible. For example, when you have a natural disaster hits like COVID, for example, or a sudden flood, crop failure, or localized economic shock, then we have to probably rely on some quick non-probability survey along with some administrative data or registrative data or even from satellite imagery to see how to combine various sources of information to produce something that would be otherwise very, very difficult and impossible sometimes using, the survey data that we know of. So basically, I would like to say there are a lot of opportunities to extend the small area work that we normally see to other research domain, but we have to think carefully how to model, how to develop a method that will be appropriate for that. So there are a lot of opportunity, for example, of using non-probability survey data in small area estimation, but we need to do research. So research should be an integral part of it. It's not just a black box where we feed in the data and out will come. A lot of research is needed. So with that, I'll stop.
Great. Thanks, Bud. So for the follow-up here, why don't we do it in this order? Matt, Ben May, and then Stephanie.
Sure, thanks, Marcus. Yeah, well, I'll just add is a lot of sort of as Partha was saying, like a lot of the typical examples you think of are geographic areas, and they're often, health or poverty or some other kind of individual characteristic. And there's also a lot of opportunities and work being done on the establishment level, talking about, businesses, employment, wages, things like that, that I've started to kind of learn more about. And as Partha said, it's the same tools. It's just it's just like the philosophy is transferring over. So I know there's a lot of colleagues that, Bureau of Labor Statistics and things like that have been working on that. So just to open up, the possibilities are bigger than just, poverty or health indicators for a geographic area.
Thank you. Ben May?
Yeah. Sorry. Sorry, my kids just called me. Yeah, Thanks, Marcus. I agree with what Partha and Matt said. I just want to add that, yeah, actually, like from the community, research community, a lot of the bounding requires like a cross section of demographic versus and geographic. However, one challenge I found is many times it's hard to get good covariates when you combine like county and then within, for example, race ethnicity groups or age groups. So we need to be careful, or maybe there are some ideas, suggestions where we can get those good auxiliary data. Another point I want to raise is like in the current, as far as I know, like the applicable smart mission projects currently carried by several of our government agencies, typically time spatial effects are not considered in the modeling. But like for non-survey data, spatial temporal modeling is very typical when you model small area estimates. Again, like it's challenging when you add more and more random effects into your model. But validation of the model will be very important. Yeah, I'll stop there. Thanks.
Thank you. Stephanie.
Yeah, and I was going to mention something that Matt briefly touched on is establishment surveys. I think part of that might be, the getting good covariates, and perhaps the skewness of the population. But I think that's an area that more research and more application could be done in. Yeah.
Okay, great. Thank you all. And I'll add one area that I'll just throw out there that I've seen it started to talk about folks with is performance measures. So a lot of when you're doing evaluation and stuff, there'll be performance measures, but there could be outcomes that could enhance those performance measures that might not be directly measured through the grantees or something from a health program or some sort of program. So using small area estimation to enhance those performance measures is another area where I've just started to talk to some folks about doing. But anyway, I am not here to talk. So I will move to the next question. So which will go to Matt first. So Matt, what is a barrier to expanding the areas in which SAE is being utilized?
Sure, thanks, Marcus. And I think this might dovetail into some other discussions, but as was mentioned earlier, we still rely on quality survey data and predictors, right? You can't predict an area if you don't have the geographic information, right, on the survey. It seems like a simple thing, but it's come up sometimes. And you need good covariates, right? At the end of the day, the covariates really drive it. So you can do a nice job, but you should temper your expectations if you don't have very many covariates, I think. And so the idea is, as we said before, it amplifies the high quality data you already have. It doesn't really replace it. I think in practice, one of the barriers is it requires a lot of statistical model runs, and there's this extra layer of abstraction. Instead of getting a data set and you do a simple summary on it, you aggregate it up to get a statistic. Now there's more of a statistical process involved. So I think it could be a little intimidating. There's maybe some barriers to understanding and what the trade-offs are. People can't say, okay, show me the data point that led to that. There's a little bit of an abstraction, I think, to overcome. So that's one issue. The other issue is you could have a survey with hundreds or thousands of measures. You're not able to produce models for all of them, right? We're more and more efficient, but we can't produce models for all of them. So it's kind of it can do in surveys. There's this line of thinking that said you should customize your weights for your outcome. You should have instead of just having a general purpose weight, every outcome should have its own weight. Well, that makes sense, except if you have lots and lots of outcomes and cross outcomes, now you have a proliferation of weights. So I think we have this issue of sort of having to prioritize what our key measures are and modeling those, and sort of having a second tier of all the other stuff. So I think that's kind of a barrier to kind of reconciling both those kinds of estimates. there's work to be done. There's work that's been done to reconcile some of those things, like benchmarking. Sometimes you have a bunch of different models. They might be slightly inconsistent. You could do benchmarking and other things to make sure they match your aggregate data sets. But I do think a lot of it comes down to there's this culture and understanding of the bottom up, working with micro data and aggregating up to get an estimate. And small area estimation is a little bit different from that. So I'll stop there. Thanks, Marcus.
All right, thank you. All right, let's do this one for the remaining responses. Let's do Partha, Ben-May. Oh no, Partha, Stephanie, Shishu, and Lisa, and then Ben-May.
So do I go first?
Yes, please.
I think Matt has some good points about we need essentially good auxiliary variable to have success in small area estimation. And there are issues. Sometimes the auxiliary variables are there. It's just that it is very difficult to access them. And so we need to think some alternative. Do we really need unit level auxiliary variable, or perhaps area level auxiliary variable, or some sub area level auxiliary will do? So we need to think how to overcome some of the problem, but it's messy and strictly restricted to privacy concern. The other thing I would like to say that in order to apply small area methodology in some complex problem, we need production ready, user-friendly software packages, So we need standardized data pipelines, open source tools, and better data sharing agreement, in my view. Thank you.
All right, Stephanie?
Yeah, I think Partha, you touched on data access for covariates, but my mind went to like data access for the data that you're trying to estimate. What your study that you're looking at. Often there's a lot of red tape in getting the data that you need to do the estimates. I mean, this is for reasonable reasons. It's for disclosure, and that, a lot of in the United States, federal data is often covered by SIPC, and it should only be used for statistical purposes. To be able to do that, there is quite a bit of legwork to get the data that you need. And so perhaps some easier access to data enclaves or other methods that folks that can get access to the data to do this. But that pairs with something else Partha mentioned, which is good software. A lot of these enclaves, it's tricky to update software quickly. Get new versions of R packages, the open source, and right now R specifically has lots of packages for small area estimation, and there's a lot out there. And so getting those regularly updated on these data enclaves so that folks can be using the latest and greatest versions. Yeah.
Okay. Ben-May?
Yeah, thanks, Marcus. Yeah, I think Matt, Partha, and Stephanie raised a great point, focusing on the data barrier. I just want to add touch a little bit on the culture barrier. Like there is a steep trust curve for stakeholders, like for model-based estimates. Small area estimation are model-based estimates, which are traditionally different from design-based estimates. A lot of the data users are more familiar with the design-based estimates, and they prefer like design-based estimates whenever possible. So there must be a transparent between, we must communicate clearly with the data users about the difference and the similarity between design-based and model-based estimates. Also, model validation is the key before we release those data to the data users to build the trust. Thanks.
Yeah, thank you. All right, I will move us along to the next question, which will go to Stephanie first. Stephanie, do you believe there's a knowledge gap in some federal or state agencies in how SAE could benefit them in analyzing their data sources? If yes, how do you think we can best close that gap?
Yeah, I think Partha touched on one thing that I was going to mention, which is that people often think of SAE for small geographic areas. And I think one knowledge gap is agencies and state and local governments understanding that SAE can be a tool for small domains, whether that's race and ethnicity or some other small population estimates. That SAE can be a tool for this. I think um, it might be better aptly named small domain estimation. And so I think that's a gap in knowledge. And we've been hitting on this a lot. SAE is better with better auxiliary data. And so I think understanding what your analytic goals are and what auxiliary data exists in the world that might be related to this, right? And so a lot of the covariates used are from very large surveys. So I think it's important that we keep these going because they help other studies. And I think that that finding that correlated data can be tricky. And so the subject matter experts may be very useful in helping know what other data exists in their field that I, as a statistician, might just be too narrow of thinking of. And so I think that's where we can get help from subject matter experts. They really know the data of their field. And another knowledge gap is that it could be and can be very difficult to implement SCE on a very special subpopulation. And that is due to the lack of good auxiliary data. And so this is not a panacea. This is not an ultimate can fix everything, right? You do need the good data to begin with. And so that's important. Yeah.
All right. So we will do for the remainder of this question, we'll do Ben May, Matt, and then Partha. And I'll just ask you to be brief, only in the sake that we can then we have one more question from me, and then I want to make sure we have plenty of time to get to the Q&A that we have. So Ben May.
Thank you. Yeah, thanks, Stephanie, for the great point about those gaps. I just want to add that there may be some awareness gap, not necessarily about the existence of SEE, but about how it could help solve specific agency problems. I think the best way to close that gap is through practical examples, demonstrate like cross-training, user-friendly tools to some agencies who are less aware of SE knowledge. Also, I think Stephanie raised a great point about small data. Yeah, like in the cancer research field, there are a lot of times people are focusing on small data, not like the population itself is very small. So sometimes applying small area estimation is not possible. So there's another challenge for the small area and small data problem. Yeah.
Thanks,
Thanks.
Matt.
Thanks. The one thing I'll add is, having worked across a few different federal agencies, is that the understanding of the mission. There's some agencies that are focused on collecting the data and disseminating it, but not doing the analysis. And they might have sister agencies that do the policy analysis. And some of these statistical models at a high level look like you're doing analysis. And so then they say, well, we just collect the data, but the agency that does the analysis say, well, we just take whatever they collect. So there's kind of this drop, this fall through the cracks of, well, somebody has to do this statistical model to have better estimates. So it could be sort of an alignment of mission that sometimes it's not obvious where this process would be and fit in.
Partha?
I would like to say the gap is that the small area estimation is too often taught and discussed as a complex academic math problem rather than a practical decision-making tool. To close this gap, we have to change how we demonstrate value. We need to stop leading with formulas and start leading with case studies. We close the gap by showing in plain terms how an agency can use its existing administrative data to transform a noisy, unusable local sample into a highly precise estimate that directly guides resource allocation. So we need motivation, case study, etc., to demonstrate the value of SAE.
All right. Well, and that is going to lead us really well into the question, which part that you are going to start us with, and I'm actually going to join it with one of the questions we got in advance, which is very similar. But the final question from me is, what education needs to be done on the data user or consumer side to have them trust model-based SAE estimates rather than direct estimates? And this is so as a person who wrote in, they used, I will use their phrase, how does SAE not be seen as just making up numbers, right? As a model when we are using a model and not direct estimates. So that's sort of the context of what people might say. So Partha, how do you respond to that sort of critique?
Okay, thank you. When we talk about data consumers resisting model-based SAE, we have to realize that the direct estimate have a powerful psychological advantage. They feel pure and free of subjective assumption. The first piece of education we must provide to data user is dispelling the illusion that direct estimates are always safe. We need to actively educate consumers on hidden danger of small sample sizes, namely extreme volatility. Sometimes we forget about that. An unbiased direct estimate with a massive coefficient of variation is practically useless for local policy. We must teach users that clinging to a noisy direct estimate just because it's design unbiased is a high risk choice for their actual implementations. Second, on the education side, we need to stop explaining SAE using complex statistical notation and start using intuitive decision-oriented concepts, something I touched on before. We need to teach data consumers how models borrow strain. That's very important. Explaining that we are not making up the data that you mentioned, but rather combining their limited local sample with robust administrative or census data. When users see the auxiliary data as a stabilizing anchor rather than a statistical black box, their trust increases. Education should not be all about the math behind the model. It should be about the logic of data integration. Finally, we must educate user on how to read model selection and diagnostic. Traditionally, users look at standard error. We need to train them to look at mean square error reduction in a practical way. Show them side-by-side maps, a jagged, unstable map of direct estimate versus a smooth, reliable map of SAE estimates, paired with clear validation metrics. Okay, I think I should stop here in the interest of time.
Yeah, and yes, no, thank you very much, Partha. I really appreciate that. So we will. I'm sorry, I will cut everyone else off on this question, unfortunately, but we will move to the Q&A. I want to make sure we get to as many of those questions as possible. And the way we will do this part of the panel is that I will ask a panelist to raise their hand and answer it. And certainly, as we go through other questions, if other panelists want to raise their hand and come back to one of these questions, they are more than welcome. But we won't go around to all four of you for all of these because I think we won't have the time. So first question is related to the last one, which is why I feel okay just moving on to it, but it's a slightly different spin. So it's more thinking about when you're talking to your clients, and we've touched on this throughout, early in the plan, talking about SAE and planning, but how would you advocate the use of SAE to clients who are on the fence about using this method? Does anyone want to take that on first?
So how do I raise the hand? I
Oh.
can.
Well, Partha, since
to.
you're off your mute and we could hear you, why don't you go ahead? I mean, no one else raised their hands. You go ahead.
Okay, so
You go
I guess
ahead.
to answer this question, we have to see whether we are really interested in answering that question, right? So we have to think about the alternative. What are the alternatives? Alternatives are direct estimates, right? And when the areas are very small, when I say area, it could mean domains also. It's very small, and sometimes no sample is available. What do? You cannot do anything with zero sample size, And if you stick to direct estimate, so you need to borrow strength from whatever data available through some reasonable working model. They are not the best model because there is no best model, right, according to George Box. But we should try to figure out a reasonable working model and try to see how we can borrow strength from other alternative databases to give some answer that looks reasonable. And of course, we have to do the validation, various ways. And there are various validation and evaluation tools available in small area estimation. We have to just see how to apply them.
Okay. So another related question that we got that sort of is a different spin on questions we've gotten so far, but I think is important to still pointedly ask. Are there places where you would say not to use SAE? Like for our audience, we're doing a real push like SAE, and you can think about it and can do these things. But are there places that the people on our call should be wary and be cautious, or are there certain situations where you recommend they know that there should be caution when using it before you go ahead and diving into using small area estimation? Anyone want to take that? Matt, please.
Yeah, I'll take a crack in this, and just hopefully it doesn't sound like I'm contradicting Partha. It's more of a follow-up is that if you have a lot of areas where you don't have any data, depending on who you talk to, they'll say, well, a model can produce an estimate there. So, but again, it depends on what the alternative is. If no estimate is better than a noisier suspect estimate. But if you are able to design it up front, you usually have a minimum sample size in all the domains you want. You're on much stronger footing, I think. So that's when you get into the area of if you don't really have any sample, you may or may not want to produce an estimate. It's worth investigating, but you might end up saying, I'm not comfortable with an estimate that doesn't have any data in that area, depending on what. So I think that's in maybe just the studies I've worked on, something that comes up.
I would like to add here that sometimes we are not really interested in estimating the levels at a certain point, but we are just interested in the change, right? So sometimes even if the model is not very good, it might do a good job in measuring change, but it may not do a good job in measuring the level.
That's a really good point. That is a really good, yeah.
And sometimes, and sometimes, we are not really interested in the estimate, but maybe we are interested in ranking, or we want to see which areas cross some threshold. In those cases, maybe even if we couldn't find very, very good covariate, we might find in our evaluation those are working well, but it needs a lot of evaluation before you implement it in a federal system.
Ben, yeah.
Yeah, I want to add to Partha's comment. Yeah, sometimes small area estimates are used for ranking. For example, county health ranking actually utilize a lot of small area estimates produced by CDC's places. So I think when there are no data, but users really want to get some estimates from there, and model-based estimates is one way to show them some data, but of course, model validation has to be demonstrate that model estimates are good. Like for our SEE website, we specifically listed a page showing limitations and uses of model-based small area estimates, explaining what the model does, and when the data are more reliant on the observed data, and when the data that are more borrowing strength from areas with the similar characteristics. I think this type of transparency is very important when you communicate to users.
All right. Partha, I see your hands up. I have three more questions I want to make sure we get to, but Partha, so please, I don't want to cut you off though. Please be brief though, but yes, thanks.
Yeah, I just wanted to add, in some situations, small area estimates is like a weighted combination of the direct and the synthetic estimate. And the synthetic part comes from a modeling, right? And the estimates are such composed that if you have large sample, it will be towards the direct. And if you have small sample, it is towards the synthetic. So in some way, even if the model is not very good, this kind of methodology can take care of this kind of problem.
Right. Okay. So for this next question, I am going to embody the questioner. So the I in here is not me, it's the questioner, but I'm going to read it so I don't misstate it. So this person, I am an epidemiologist at the state level, and one of the projects our team oversees is PRAMS, the Pregnancy Risk Assessment Monitoring System. Our local health departments are very interested in small area estimates, and we would love to share those with them. However, the small local health departments do not have enough data for stable estimates. This creates an equity issue for us in the data we can share with our local health departments and impacts their ability to design and implement programs specific to their populations. Are there any methods or ways to think about SAE that could be helpful in working with smaller jurisdictions? Stephanie, please.
Yeah, I mean, I think this could be. I'm not familiar with Graham's outcomes and things. This definitely could be the perfect use case of SAE for decision makers to get these more local estimates. And so it is often seen SAE as a tool to help with equity in the lack of, in the sense of not having data for every, in this case, area, sometimes a subpopulation. So I see SAE as a tool to help with an equity issue, and especially these likely lower resourced areas. Yeah. So I definitely would look into it and talk to some folks that could help you out. Yeah.
All right, 7 minutes. I have two questions, and obviously we want to come back to that one. We can, but let me do this next one here. So this gets back to sort of the first question we were talking about in terms of planning for SAE before data collection. So, and this is a very practical question, so I think it's great for this panel. What are the tasks and budgetary implications beyond the quote unquote usual data collection efforts that we need to think about when we're embedding SAE into the design and the front sample design steps? Stephanie, you want to go?
Sorry.
Sure. Yeah.
I think a key aspect is in if you have to have a clustered design, that's going to lend itself to being the hardest to overcome because you're definitely going to have areas if you're looking at geographic areas that won't have samples. So trying to reduce the amount of clustering in your sample. And then also your sample allocation is important. And we talked about your allocation might need more to smaller areas than you thought, which could be a little more expensive, but you could thus maybe reduce some of the sample size in the areas that were going to get a large allocation in the first place. And so I think the sample allocation is a very key step in doing this, and looking at some hypotheticals of how many estimates you could get with the cost of some statistical time for the small area estimation, doing that calculation, comparing with data collection, and maybe how many more completes you would need. I've not done that particular analysis, but it seems like a good one to do up front. Yeah, Martha.
Martha?
Yeah, in small area literature, there are few papers that talk about overall strategy, meaning that what you should do at the design stage, if you know the plan domain, you know in advance that this is something you have to do for small areas, and the analysis stage. So as Stephanie says, there are few things we have to keep in mind, because in the survey design, we have the stratification. More strata you have, the better for small area, but it has implication on the budget, right? And so that's why we do clustering, but clustering is not very good for small area estimation because many of these areas will go unrepresented. And then there is this sample allocation thing. So we typically do proportional allocation, Neyman allocation, things like that. But if we know in advance that we have to do estimation for the planned domain, there are some strategies available in small area estimation that one can look at.
Matt, real quick, and there's one question that I think will be perfect to end with, but go ahead, Matt.
Sure, and I'll see if I can copy this into chat. So there's a particular reference. Rachel Harder and other colleagues had a sort of a step-by-step guide on a recent study of sort of like the pipeline of putting these things together. Because my interpretation of the question was sort of like, if I have X number of dollars or hours for the data collection, what's the relative amount? How long do I have to add on to the analysis part of it? And I think that could be helpful. So I'll just add it into the chat.
Thanks, man. And so real quick, because this is a good way to end, and then I want to leave a minute for me just to wrap it up, so one person can answer this. But the question is, this is really good for this audience. What are the tools they need to know about, right? We've talked about this SA and all this stuff, but what are tools that a person might need, or is there something they need to buy, or is it all freeware? Like, what can someone just quickly enlighten us, and what are the types of things someone might need to implement SA? Stephanie.
I think I mentioned before, I think um, the software R is, I mean, there's so many package is actually at APOR, this most recent APOR conference, Lauren Rawson from NCHS presented on what was called I think a SAE toolkit and looking at various options in R for different types of models and what options are out there, especially looking at if you're looking towards Bayesian models, we've got Stan and some other tools that you can crack into. But those might be if you're wanting to do a super custom model, but there's so much what I would call off the shelf right now. And even like there's this one package that I found, Tip SAE, that even has a Shiny app, so like a more like an interactive app. And I think that could be the most approachable starting point just to play a little bit with some models, to have like an app to actually do it. I don't think that would be great long term for like a production to be using an app for it, but to get you a feel for what you need and what the inputs are, I think that could be a good start. Yeah.
And this is the type of question that we'll definitely make sure we include in the Q&A so it's in writing and posted. Um, so with that, I want to say a really big thank you to our panelists. Thank you, thank you, thank you so much. This was wonderful. Um, and then just as a reminder, we will have another panel in a month on AI and the future of survey research. And all of the material, the recording, the Q&A document it might take us a little bit to post that, but post that. The slides will all be posted on the event page, and we will be sending out an email with a link to that event page for everyone that registers. So everyone on this call will get that. But I want to thank you guys. We had a huge audience today, so I really appreciate everyone joining us today. I hope you found this useful. If you have any feedback for us, we would love to hear it as well. And with that, I know we're out of time. So have a great rest of your Friday and enjoy your weekend. Thank you, everybody.
Thanks.
Really appreciate it.
Thank you.
Thank
Bye.
you.